Okay, one of our other questions besides is it safe to swim was, is water quality getting better or worse? When you think about water quality, it's hard to say, how are you going to define good or bad? But one of the best indicators of overall water quality is the dissolved oxygen in milligrams per liter. Just like you need oxygen to breathe, fish need oxygen in the water to be able to live. And the higher those oxygen levels are, usually the more diversity you can have and the healthier the water is. It should be at least 5 milligrams per liter. There's another term that we use when we're monitoring called dissolved oxygen saturation. That is kind of like giving the water a grade. It's like, given the temperature of this water, is it holding as much as it can hold? So we know that warm water holds less oxygen than cold water. And the saturation is basically a percentage of the measured dissolved oxygen divided by what the water could hold at that temperature and multiply that by 100%. So if it's between 90 and 100%, it's like getting an A. If it's between 60 and 70%, it's like getting a D. So both of those parameters are things that our water monitors gather, and we can use those to compare streams as over time. All right, there are 70 sites listed for Dog River Clearwater Revival on the Alabama Water Watch website. Now, all 70 of them are not monitored, but every one of those has a little bit of data. Of them, 26 have at least 5 years of data between 1999 and 2025. And if I look at the trends in those, and I could just look at each individual site, 17 of those sites showed downward trends in dissolved oxygen. 3 sites had no change, and 6 showed improvement over time. So looking at it that way, 65% of our sites are showing downward trends if I look at that long data string. If I look at just the last 5 years of data, instead of the long term that goes all the way back to almost 1999, if I look at that, 22 sites actually show improvement over the last 5 years. So 68% of the sites are showing improvement from the last 5 years. And only 15 of those showed, or only 7 of those showed downward trends. So it looks like things are actually getting better. More improvement, much more than we had if we look at the long-term data. So it sort of implies that things got bad for a while and now maybe they're getting a little bit better. I'd like to show you some graphs of different sites so you get an idea of what we're looking at. This is Eric Holliday's site, which is near the Scenic Yacht Basin. On this axis, we have dissolved oxygen, and here's that 5 milligrams per liter, which means low oxygen. So you can see that most of the time, Eric's site has adequate dissolved oxygen, but the trend over the long haul is slowly downward. This is dissolved oxygen saturation. And again, here's low dissolved oxygen. That's 60%. That would be the D line. And you see that most of the time Eric's has been okay, but again, a slow, steady decline over the amount of time that this site has been monitored. Eric's site has the longest continuous string of data. The other ones have data starting in like 2015, 2016, but then there's a gap before they go back to the 1999 to like 2005, 2010. So this is an indicator that maybe things are, at this particular place, not getting better, but getting slowly worse. This is another site. This is Spring Creek. Again, here's the dissolved oxygen. This one shows pretty good. Here's the big gap. Things are pretty good. And this more recent stuff is a little bit lower. Again, the trend is slowly downward. The dissolved oxygen saturation, same thing. You've got the old data, and you've got the last 10 years of data. And you can see that, again, this trend is slightly downward when you look at the long string of data. Now, not all of our sites are good. Some of our sites are really problematic, and this is one of our problem children. This is the Slava Creek at McVeigh where the litter trap is, and this has 25 years of data with only a short gap. These overlap because there's so much variation in them, but the red again is the dissolved oxygen. You can see that frequently is the dissolved oxygen below. Here's the 5 line right here. Lots of these red dots are below that 5 milligrams per liter. If you look at the DO saturation, which is the grade, again, decreasing over time. And a lot of these, I mean, here's 40s, 20s. Rarely does this site make a very good grade. And even way back in time, an 80 was about what you would have seen. Sometimes you have these really high peaks like that, but that's due to an algal bloom where there's a lot of oxygen added all of a sudden and then a lot of oxygen taken out really fast when those algae die. So this is one of our problem places. And I want you to understand why it's so bad, because a lot of people just don't realize what's wrong there. The Slava Creek is right here. The site that we're looking at is right here. And this part of the watershed, this is a topographic map, basically. All of this in green is very, very flat. If you're out here, you've got hills, it's fairly high. But there are some man-made changes that affected this particular stream. And I want to look at those changes just briefly. Back in the day, the Slava Creek used to have headwaters that went all the way out to University Boulevard. Here's Bolton Branch. It came all the way across here and went all the way out to University Boulevard, out there where the hills were, okay? In the 50s, they built Interstate 65. And in doing that, they actually drained the swamp that used to be here. They dug this canal called the Montlamar Canal. And the Montlamar Canal actually took the headwaters for those 2 streams, the Slava and Bolton. They now go down the Montlamar Canal. The interstate acts as a dam. So a Slava Creek over here no longer has access to its headwaters. It would be fresh water pushing things on down with a nice flow. That doesn't happen anymore. That water instead is collected by the Montlamar Canal and goes all the way down here to Moore Creek and dumps out into Dog River down here, okay? So because it lacks headwaters, the Slava Creek is relatively stagnant. It's possible for salt water to move way up it, and it really doesn't have a good strong flow at all. It's just a completely different river from what it used to be. And I think it's important to understand that that's a modification that we did engineering-wise that probably they didn't think about what they were doing at the time, but it's very difficult to fix. You can't rejoin this anymore. But if you had to compare water quality here and over here, you'd be surprised at the difference in those two. This is the dissolved oxygen trend for the last 5 years at Eslava. Remember I said sometimes if we looked at the last 5 years, things got better. And for the last 5 years, although it's still bad, it actually seems to be slowly improving. Why? I honestly don't know, except maybe there's no more construction and there's no more adding any more impermeable surfaces in that watershed. It's pretty much as developed as it's going to get. And this is a comparison between, no, this is not a comparison, I'm sorry. I want you again to realize that not all sites are bad. This is the Montlamar Canal itself at Michael Boulevard. And you'll see that dissolved oxygen is increasing over time and the DO saturation is increasing over time. This is one of our sites that's really getting better. And this is back up there. Montlamar is up by, this would be close to the Home Depot, that little creek that runs behind the Home Depot on Montlamar Boulevard. And this is the dissolved oxygen saturation at Montlamar, at Azalea Road, and Eslava Creek at McVeigh. So this would be taking those headwaters and comparing them to that creek that was left behind. And what you see here is the red is the ones, this is the values for the Montlamar Canal. The green is from Eslava Creek. The Montlamar Canal, because it has the headwaters, has higher dissolved oxygen than Eslava Creek, which no longer has headwaters available to it. It's interesting to be able to compare them like this and know that if you wanted to swim or you wanted to fish, you're probably better fishing in canal than you are fishing in what looks like a normal river. Another one of our sites has been traditionally bad is Perch Creek. Perch Creek is down near the Dog River Bridge, and this is the bridge over Perch Creek for Dauphin Island Parkway. You can see lines on the bridge where the water used to be up to here. This is an incredibly low bridge. You can't get under it, or you could not get under it on a high tide. Because it hung down in the water, it really blocked a certain amount of flow into Perch Creek. When the tide's high, most of the oxygen's in the surface water. The surface water was blocked because this bridge was hanging down in the water. This is what the graph looks like for Perch Creek and Terrell Road, which is where our site is. And you can see that dissolved oxygen has been really, really incredibly low. We had a monitor here for a long time doing great, and then that monitor quit. So we have a data gap here. And it's sad that the data gap is where it is because they fixed the bridge and they raised the bridge. But you will notice that since the bridge was raised, now the dissolved oxygen saturation and the dissolved oxygen are both showing upward trends, and they are actually pulling this up. So fixing that bridge actually helped that little creek. It hasn't solved it, but it has certainly helped it to do better than it was before. Questions about trends?
Well, you sort of answered the questions as you went along. I'm sure one of the questions that you answered that's difficult is, how do you make rivers flow better when the engineering from improvements on interstates happen? And is there anything? You pretty much said it's difficult to do. Is there anything that individuals can do for dissolved oxygen? I know that's
well, and it's, yes, there are some things that individuals can do because low dissolved oxygen is really pushed by the organic load that happens to be in the water, things that have to decompose. So personally living here on Halls Mill Creek, sometimes I see when my neighbors upstream have mowed their grass and they've run the lawnmower right along the bulkhead and they've thrown all the grass clippings out in the river. Anything like that that adds an organic load to the river is going to negatively affect the dissolved oxygen. So I think that's something that everybody can do. I mean, we clean up the leaves. We don't let them go down the gutters. We talk to people who are throwing things in the river. Don't do that. That's one thing. The other thing is there is an engineering solution for Oslava Creek that I would love to, I wish we had, maybe we have some engineers in Dog River Clearwater Revival that are looking for a strange project. You know how you put air stones in aquariums and it's a little pump and it just pumps air down into the water to keep it aerated? They make those larger ones that actually you could put in the water. So it's a pipe. If it was run on solar power so that it didn't have to be powered, then during the daytime, it could actually pump oxygen into the water. And I think something like that, I mean, I know they make bubble screens for actually diverting litter in some of the streams in Europe. But I think the exploration of some kind of an aeration system upstream from the litter trap, probably, and maybe associated with the litter trap, might be something that would help that particular stream. I mean, there's no other way. You can't reconnect it, but you could provide oxygen like that.
That makes sense to me. What a great sounding project.
if you have people, and
Right.
We have so many different talents that we don't use. Maybe we have a talent like that out there.
Well, it's certainly worth exploring. Thank you for that.
So I had a question. How does, these invasive plants that we see kind of coming and going that will clog up the canals from time to time, how does that affect dissolved oxygen levels?
As long as they're photosynthesizing, they're having a positive effect. It's like that nasty algal mat, that filamentous algae that comes in sometimes. It just looks like big green nasty bubbles. But when it's photosynthesizing, it's actually producing oxygen. So that part of it, it's a plus. If it dies, it's a minus. And this is one of the things I always hate about people wanting to spray it, because if you spray anything like that, when it dies, you're just adding an organic load to the river. And when that decomposes, you're going to suck a lot out.